My name is Muhammad Amin bin Mazlan. I'm going to explain about partial fraction. By the end of this topic, students should be able to define partial fraction, identify the different cases of partial fraction, decompose fraction into partial fraction, the application in real life. Okay, what are partial fraction? We usually do like this, right? But how do we go in the opposite direction like this? That is what we are going to discover, how to find the part that make the single fraction the partial fraction. Partial fraction also we can call a way of breaking apart fraction with polynomial in them, like this. Partial fraction decomposition. So let me show you how to do it. The method is called partial fraction decomposition and goes like this. Step 1, factor the bottom and become like this. Step 2, write one partial fraction for each of those factors, and we must put the constant a and b. Step 3, multiply through by the bottom so we no longer have the fraction. We multiply both sides with the bottom and we got like this. Step 4, now find the constant a and b, substituting the roots of zeros of s minus 2, s plus 1. Okay, for s plus 1, we got, and we must substitute, and we got b equal to 3. Meanwhile, for s minus 2, we substitute, we got a equal to 2. Yeah. Then we put back a and b like this. We got the answer like this. Firstly, this only works for proper rational expression where the degree of the top is less than the bottom. The degree is the largest exponent the variable has. Like this, the top has only 1 degree, meanwhile the bottom degree are 3. They are what we call proper fraction. The degree of the top is less than the degree of the bottom. And the improper, the degree of the top is greater than or equal to the degree of the bottom, like this. S the power of 2, meanwhile s at the bottom is the power of 1. If your expression is improper, then do the polynomial long division first. We must name the top polynomial as the numerator and the bottom as the denominator. Step 1. Divide the first term of the numerator by the first term of the denominator and put that in the answer. We must divide this by this. Step 2. Multiply the denominator by the answer. Put that below the denominator. And step 3, subtract to create a new polynomial. So this is what we do. We multiply first, then we must subtract, then we multiply until there are no more to subtract. Then we have our new polynomial. When you have a quadratic factor, you need to include this partial fraction, as plus b over your quadratic, like this. This is the quadratic, and meanwhile this is the repeated. So we must use the constant a over s plus 3 plus once again b over s plus 3 the power of 2, and for the quadratic we must use cs plus d over s squared plus 3. Okay, after we find the constant, we can integrate the whole fraction. After we integrate, we got the integration of 1 over s plus 5 is equal to ln s plus 5. Meanwhile, the integration of 1 over s minus 3 is ln s minus 3. Then we must simplify the answer, and we got 1 over 8 ln s plus 9 the power of 9 over s minus 3 plus c, then c is the constant of integration. Application in real life. Partial fraction decomposition is a necessary step in the integration of the second function. Integration of the second function is necessary to draw a Mercator map projection. This map projection is important because it is the only conformal projection. Doesn't distort shapes that show through compass directions as constant angles. For these reasons, the Mercator projection was widely used in navigation and is the one used in Google Maps and most other navigation software today. Thank you. That's all from me.
Hello, my name is Mama Abra bin Charlene. Today I'm going to explain about trigonometric substitution. By the end of this lesson, a student should be able to compute the integrals of a wide variety of functions by using the technique of trigonometric substitution by hand. Also, students should be able to combine this technique with the other integration techniques to integrate. Okay, let's proceed. What is trigonometric substitution? In mathematics, trigonometric substitution is the substitution of trigonometric functions for other expressions, while in calculus, trigonometric substitution is a technique for evaluating integral. One may use the trigonometric identities to simplify certain integrals containing radical expressions. Here is the differentiation formulas and integration formulas table, which is commonly used in trigonometric substitution. When we are facing with integrals that involve radicals of the form such as square root of x squared minus x squared, square root of x squared minus s squared, and square root of x squared plus a squared, we can make substitutions that involve trigonometric functions to eliminate the radical. Okay, let's see the example below. To eliminate the radical in the expression of square root s squared minus x squared, we can make the substitution of x equal to a sine theta, which negative pi over 2 is less or equal to theta, and theta is less or equal to pi over 2. Please take note that theta must be limited to the range of the inverse sine function. Then we can substitute the value of x into the expression. So the expression will become square root of s squared minus a squared sine squared theta, which we can simplify as square root of a squared bracket 1 minus sine squared theta, and close the bracket. 1 minus sine squared theta can be simplified as cos squared theta, which is why we got the equation at the below, a square root of cos squared theta. Then we can find the square root of cos squared theta, which will become cos theta, and finally we will get the answer of a cos theta. Okay, now we can continue. Alright, here are the example of radical form of expression. We can try this at home. Okay, let's proceed. Okay, the table below lists the proper trigonometric substitution that will enable us to integrate functions with radical expression in the form above. Okay, on the first column we got is expressions in integrand, the second column is the substitution, and the third column is the identity needed. Okay. In the second column are listed the most common substitution. They come from the reference right triangle as shown in the figure below. We want any of the substitution we use in the integration to be reversible, so we can change back to the original variable afterward. The right triangle in the figure below will help us reverse our substitution. Okay, now let's evaluate integrals of dx over x squared square root of 4 minus x squared. Okay, our goal first is to eliminate the radical. To do so, look up to the table before and make the substitution, which is x will become 2 sine theta, and negative pi over 2 is less than or equal to theta, and theta will be less than or equal to pi over 2. So that dx over d theta will equal to 2 cosine theta. Then we can simplify this equation as dx equals to 2 cosine theta d theta. Okay, let's proceed. After we find the value of this value, x equal to 2 sine theta and dx equal to 2 cosine theta d theta, we can substitute the value into this equation, which dx will become 2 cosine theta d theta, and this equation below will become 2 sine theta squared square root of 4 minus 4 sine squared theta. Then we can simplify this expression, which will become 2 cosine theta d theta over 2 sine theta squared 2 cosine theta. And then we can take out this fraction, which will become 1 over 4 integrals of d theta and sine squared theta. Since cosine here and here, we can eliminate them. So the next expression will be 1 over 4 d theta over sine squared theta. And then we will get 1 over 4 cosecant squared theta d theta, which can be simplified as which can be integrated as negative 1 over 4 cotangent theta plus c. Okay, now let's proceed. Okay, now we are done with integrating, but to complete the solution, we need to express cotangent theta in terms of x. By looking at the figure of triangles above, from this figure. Okay, now. Okay, by the figure of triangles, we can see that the second triangles represent our case, with a equals to 2. So, x equals sin theta and 2 cosine theta equal square root of 4 minus x squared. So, it can be written as cotangent theta equals to square root of 4 minus x squared over x. Okay, now we have get the value of cotangent theta, which is equal to square root of 4 minus x squared over x. And okay, let's have a look at the rules below. Cotangent theta is equal to cosine theta over sine theta. Okay, now we can substitute this equation into this previous result of integration. We can substitute this cotangent, which is equal to cosine theta over sine theta, into negative 1 over 4 cotangent theta plus c. So now we will get integrals of dx over x squared square root of 4 minus x squared. We can substitute the value of cotangent here. So the equation will become negative 1 over 4 square root of 4 minus x squared over x plus c. Okay, here is the final answer of this trigonometric substitution question. Okay, now we have another example. Evaluate integrals of square root of x squared minus 3 over x dx. Okay, as usual, we want first to eliminate the radical. So we have to use the table previous and substitute x equal to square root of 3 secant theta. Then we find the dx of x, which will become square root of 3 secant theta tangent theta d theta. Then we substitute back the equation into the integrals. So the integrals will be square root of 3 secant squared theta minus 3 over square root 3 secant theta square root 3 secant theta tangent theta d theta. And the final result will be square root of 3 integrals of tangent theta square root of 3 integrals tangent squared theta d theta. After we find the integrals, we have to use the integral identity from the section of trigonometric integrals to obtain this expression, and we have to let m equals to 2 to obtain this expression. And finally, we have to look at the previous triangle figures, and the third triangle represents our case with a equal to square root of 3. So x will be equal to square root of 3 secant theta, and cosine x will be equal to square root of 3 over x, which will make tangent theta equal to square root of x squared minus 3 over square root 3. Then we substitute this equation into the integrals, and we will find the final product. Here are the exercise. Evaluate integrals of dx over x squared square root x squared plus 1. You can pause the video to find the answer. Okay, let's proceed. So here is the solution. Have you done it right? Okay, that's all for me. Thank you, have a nice day, and stay safe.